Okay, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. So this is our chapter 4, a new chapter. This is not included in your test 1, but it will cover in chapter 2. Sorry, in test 2, not in test 1. So again, test 1, Markov chain and long run behavior. When you refer to our scheme of work, it's only in chapter 3, where focus on the Markov chain and the long run behavior of Markov chain. Now we move to new chapter, chapter 4, stochastic modeling for actuarial application for the Markov process model. So before this, when we talk about the Markov process model, we know that Markov process model, they need to follow the Markov property, and under discrete state space and discrete time set, we call that as a Markov chain or discrete time Markov chain. Now, under Markov process, we have two types of Markov process. The first one, like I mentioned just now, which is Markov chain. Again, Markov chain, state space discrete, time set also discrete. For chapter 4, 5, and 6, we go to in deep about the Markov jump process, another types of Markov process, which is again Markov jump process. Markov jump process, also known as the continuous Markov chain, where the stochastic process has a discrete state space and
Madam,
yeah,
screen tak bergerak lah rasanya.
belum bergerak lagi.
Oh, ya ke? Okay.
Okay.
Sorry.
Sorry, it's okay. So again, Markov process ada dua, Markov chain yang kita dah belajar. Now we move to Markov jump process. Again, Markov jump process, another name is continuous Markov chain, where the continuous Markov chain or Markov jump process is the stochastic process, ada or has a discrete state space and continuous time set. Again, Markov chain, discrete state space with a discrete time set. Now, kita akan pergi ke discrete state space and continuous time set. Okay, for Markov process model, we're going to look about the features of a Markov process. But before we go in deep about the Markov process or Markov jump process, we need to know Markov jump process, they are the discrete state space and continuous time set. Okay, untuk continuous time set, they have two types of continuous time set. They are the time homogeneous Markov jump process and time inhomogeneous Markov jump process. Before we go in deep, let's take a look at the features of a Markov process. Okay, when we under chapter 3, we know that Markov process is a stochastic process that follows the Markov property. What is a Markov property? States that the future is independent of the past while the present is known. We don't know the past behavior. We only know about the present. So first, before we look at notation from the Markov perspective, we recall back the notation from the actuarial mathematics that you have learned in ASC425 and ASC475. So we set out a list of notation under the Markov process by recalling the notation from actuarial mathematics. Selama ni, you nampak the notation here, mu x, TPX, TQX datang daripada actuarial maths. Kita boleh baca TPX, TQX, mu x from Markov process punya perspective. Both give the same meaning. Okay, now recall back your actuarial mathematics. Mu x stands for the transition rates, or also known as mortality rates. Okay. TPX, what is a TPX? TPX is the probability that a person age X survive for at least another T years. Or this one we call has a survival or survive for the next T years. Okay. TPX also known as a survival probability. Again, TPX is the probability that a person age X survive for at least another T years, or we can write the probability alive X plus T given that alive at age X. Okay, so TQX is a probability that a person age X dies within the next T years, or we also can find our TQX through 1 minus TPX. TPX adalah survival probability or occupancy probability, while TQX is a transitions probability. So again, TQX adalah probability dying at age X plus C given that alive at age X. Okay, itu adalah from notation, the actuarial mathematics notations. Next is notation for Markov process. Okay, so kita tengok daripada perspektif Markov process, even they give the same meaning from the actuarial mathematics. So now we look at Pij from time S to time T. So bear in your mind, now we are in continuous time. Kita kena ada Pij kita daripada satu time point kepada satu time point. Daripada time S to S plus T. Okay. So probability from state I to state J from time S to time T. What does it mean? So Pij to S plus T is the probability that the process is in state J at time S plus T, given that it is in state I at time S. Just now, I mentioned that under continuous time set, we have two types of continuous time set. The first one is time homogeneous process. Maksudnya bila dia homo, dia punya probability will be the same from one time point to another time point. So for time homogeneous process, the start time S is irrelevant for, all that matter is the length durations of time T. So for time homogeneous process, it means that this process not depend on S. Okay, kalau dalam you belajar dekat actuarial mathematics, which is Hx. So we also can say that for time homogeneous process, this process not depend on H or not depend on X, but depend on length of durations. Okay, here we can say that the probability from state I to state J from time 0 to T is actually equals to probability from I to J from time S to S plus T. When we see in terms of length of durations, where T minus 0 is also equals to T, S plus T minus S is also equals to T. Only for time homogeneous, we can say both is equals to Pij at time T. Okay, that one is for time homogeneous process. For time inhomogeneous process, masa dia tak sama. Okay, pukul daripada 2 ke 4 tak sama daripada 4 ke 6. Even the length is still the same, 2. This is time inhomogeneous process where the notation will remain as the probability from state I to state J from time S to S plus T. Okay, this one, it's not equal to the probability from state I to state J from time M to M plus T. Remember, we have two time set. The first one time homo, the second one time inhomo. Another notation for Markov process is your mu ij in the bracket S. Okay, mu ij at time S is the transition rate from state I to state J at time S. Okay, here we also have two time set. The first one, time homogeneous process. The transition rates are constant and will be denoted only by mu ij. Okay, but for time inhomogeneous, you need to take note or remain your S. So for time inhomogeneous process, the transition rates are not constant and the notations will remain as mu ij in the bracket S in the functions of S. Questions? Ada soalan? Faika, do you have any question, Faika?
Tak ada, madam.
Okay, then we can move to a simple model for Markov model. We can say two-state Markov model. Okay, this is also known the best example, simple alive dead model that you have learned in your ASC425 and ASC475. So in this subtopic, we will look at the problems formulations which examine the stochastic process by which a person transition from one state alive to another dead. Before this, in our Markov chain, the arrow give you the probability, but now the arrow not give you the probability, but give you in terms of transition rate. Okay, kalau you belajar dalam actual maths, mu x tu you selalu panggil dia apa? Syaril. Syaril Rizkin. Mu x selalu you panggil apa? Syahril ada?
Ada.
Okay.
Saya panggil force of mortality.
Yes, force of mortality. So another name for the transition rate, you also can call, kalau dalam suatu situasi ni lah, mu x, alive to death. In your actual math, you call that as a force of mortality. You also can call force of transition rate. You also can call transitions intensity. So in general, okay, kalau yang ni kebetulan alive and dead. Kalau dalam keadaan mesin rosak ke apa ke, kita selalu panggil transitions intensity, transition rates. Ataupun dia force of transition rates. Kenapa dia panggil Markov jump process? Dia instantaneously change. Okay, kalau you belajar TPX mu x plus T, a person at the age of X will survive up to T and instantaneously die at mu x plus T. Forced untuk mati. Sebab apa? Dekat time pukul 2 tu, mungkin dia mati dalam continuous, dia mati pop dekat point 2 tu, daripada dia hidup dia mati dalam beberapa second. Tapi kita tak boleh declare second, kita declare dia instantaneously, which is your transition rate. Dia transit from state alive to dead instantaneously. Okay, that particular point dia mati kat situ. Daripada dia hidup. Tak adalah kalau discrete 1 ke 2, 2 ke 3. Dia hidup sampai 2 tahun ketiga dia mati. Tapi in between kita tak tahu dia mati bila, tapi dia declare mati dalam tahun ketiga. But in continuous, at time point tu, daripada time point 2 tu, dia terus jump pergi ke mati. At that straight line 2 tu, dia mati on that particular point juga. Even dia mati dalam time 2, kalau ikut logik, dia ada mati perbezaan time dia in second ke in minute ke, that we need to take into our concern lah. That's why we have our transition rate. Okay. If you recall back your actuarial mathematics, just now mentioned by Sharia, we have force of mortality, and we know that our force of mortality for a person at the age of 70 or 90, which supposed to be higher compared to a person at the age of 30. Okay, kadar ataupun force of mortality umur 30 kuranglah berbanding dengan force of mortality a person at the age of 75, 80, 90 and above. Okay, so if you look at here, we have a transitions diagram. Okay, so this is not a probability, this is a transition rate. So we have alive, ada mu x to d, which is dead. Kita ada dua state, alive and dead. In general, depending on age, this alive dead model will produce varied transition rates, resulting in distinct TQX and TPX. So however, this model can be seen in both time homogeneous and time inhomogeneous. Specifically, for this model, TQX is also known as the transitions probability, and TPX is known as the survival or occupancy probabilities. Okay, if you look at here, we have mu x. X is in terms of time lah, S. So dalam ni kita tahu, kalau kita tengok model ni, this model is more on time inhomogeneous. Force of mortality for the person at the age of X, which is X equals to 30, is different with force of mortality for the person at the age of 70, where this one we can say mu X dia berbeza-beza, where it depend on age. Maka dia adalah time inhomogeneous. But however, this model can be seen. Okay, depends on the question, depends on the scenario. This model can be seen in both time homogeneous and also in time inhomogeneous. Okay, so based on model above, a life and death model, we can define the transitions probability, where we have TQX. Our TQX or transitions probability adalah probability from alive to dead at the age of X to X plus T. Or we can write in our Markov notations, or in Markov forms, where the probability for the person in the death state at hx plus t, given that person in a life state at hx, which is, we can see here, the probability of x plus t equals to d, given that process at hx equals to a. Okay, this is our transitions probability, which is our TQX. We also can find our TQX by using 1 minus TPX. So what is our TPX? Again, TPX is occupancy or survival probability. So TPX is a PAA from HX to X plus T, or the probability person in a live state at HX plus T, given that person in a live state at HX, or the process at HX plus T equals to A, given that the process at HX equals to A. So now we have two types of probability: transitions probability and occupancy or survival probabilities. Ada soalan? Tak ada soalan. So we know that X tadi tu kat dalam equation atas tadi tu, X adalah a Markov process where process at hx equals to A refer to the process being in state alive at time X. Or here we have X tu adalah H. So the probability that a person being alive at a given age will die at any subsequent age is governed by the age-dependent transitions intensity, which is mu x plus t in the bracket t greater than or equal 0, where here we have mu x plus t. So mu x plus t, where they can die at any subsequent age. So we can say mu x plus t is actually based on the limit dt approaches 0 for the dt qx plus t divided by dt. If you look at the equation 5, where we involve with the differential equations, which is dt, can someone tell me why this equation 5 relates with the differential equations? And in simple word, why you study differential equations before we go in the calculation part? Kenapa kita kena belajar differential equations? And these differential equations relate with our transitions intensity. Siapa boleh jawab? Tak ada. Kalis? Muhammad Kalis. Akif. Why you study your calculus 1, calculus 2, calculus 3, and you need to calculate related to differential equations. Kenapa you kena belajar differential equations and how to relate these differential equations into our equation 5? Kalis, boleh cuba bagi pandangan? Kalis tak ada?
Doktor?
Ya.
Sekali lagi boleh, Doktor?
Kenapa you belajar differential equation dalam calculus?
Nak tahu rate of change ke, Doktor?
Yes, thank you very much, Kalis. Okay.
Doktor.
Nah, maksudnya you berfungsi, you punya kegunaan calculus. Sebab in the industry, they didn't apply a lot of continuous punya equations. Okay, I have discussed with one of the industrial supervisor when dia mention dekat luar kita pakai discrete, kita tak pakai continuous. So why we study so hard about the continuous punya equations, distributions and so on. Okay, dia cuma pakai discrete. Kalau nak cari probability, X times the probability. Okay, cari frequency, cari standard calculation without using differential equations and all the continuous punya integrations by part and so on, semua tu. But mentions by Kalis, we have some reason why we study differential equations. Okay, if you look at here, transitions intensity, dia boleh mati at any subsequent age, meaning that differential equations are equations that account for any functions with its derivative. Meaning that these equations are often used to describe the the way things change over time. Okay, bila dia bertukar sekelip mata dalam masa, dalam in terms of time, it's better to apply differential equations because it can help us to make predictions and account for both initial conditions and the evolutions of variables. So that's why we need to include our equation later on by using differential equations. Thank you, guys. Okay, so before we go to or estimate or compute the transitions probability, this mu x plus t is sometimes again referred to as a force of transitions or transition rates or transitions intensity. So now we need to have three assumptions in order for us to work out our transitions probability. The first underlying assumptions is the probability that a person at any given age will be found in either state at any subsequent age depends only on the age involved and on the current state occupied. Meaning that these assumptions, the first assumptions, follow Markov model or Markov property. Salah satu assumptions dia follow Markov property. Okay, the second assumptions where we need to cater about the short time interval of length dt, because dt is the change over time. So look at our transitions intensity where we have mu x plus t, where mu x plus t relate with the dt qx plus t. So what is a dt qx plus t? A person at the age of x plus t instantaneously die at dt. Maka dia adalah sama dengan mu x plus t dt plus 0 dt. 0 dt is just a functions where we can say that this, usually kalau you refer notes, dia panggil little zero. Okay, so this 0 dt is a significantly small where we can refer any functions when you take limit t approach to 0, then you will get, for example, like gt or functions of t divided by t is equals to 0. So these functions t or gt tend to 0 faster than t itself. Okay, kadar dia kecil nak sampai ke 0 lebih cepat daripada t itu. Mungkin t dalam bentuk minit, dt dalam bentuk second. So perubahan dia nak kecil ke ataupun near to 0 faster than t itself. Okay, when come to this short time interval, in other words, I can say that the probability of dying in a very short time interval, dt, is equal to the transitions intensity multiplied by the time interval and plus a small correction terms. So this is equivalent to assuming that dt qx plus t it's near to mu x plus t dt, where 0 dt is actually equals to or near to 0. So we can leave it our 0 dt and for all t greater than 0. Remember that the functions 0 dt, or we can write gt, is said to be 0 delta, or sorry, 0 dt if we put limit t equals to 0. Okay, so next is assumptions number 3, where mu x plus t is a constant for t in between 0 to 1. Untuk assumptions 3, okay, there's a lot of investigations. So where the investigations consist of many observations of small segment of lifetime. For example, single year of age, where assumption 3 simplify the model by treating the transitions intensity as a constant for all individual age x for the last birthday. So this does not mean that we believe that the transition intensity will increase by a discrete step when an individual reaches hx plus 1, although this is a consequence of the assumptions. This is an assumption to show that mu x plus c is a constant mu. Now, when we talk about these three assumptions, back to our main objective, where our main objective is to determine our TPX and also our TQX. Okay, so Now, the questions remain, how do we compute the transitions probability or the occupancy probability? So now let's consider our TPX, or the occupancy or survival probability, in a general Markov process notations, where our occupancy or survival probability is a P alive to alive at the age of X to X plus T plus dt, conditions on the state occupied at age X plus T. Okay, so we can solve these equations by defining your forward differential equations, which is d dt for the PAA x plus t, or delta divided by delta t PAA x to x plus t. So in order to solve for these equations, or in order to solve for our occupancy or survival probability, we need to apply Chapman-Kolmogorov equations and also assumptions 1 and assumptions 2. Okay, applying Chapman-Kolmogorov equations and both assumptions 1 and 2, we have these all steps in order to get our PAA x to x plus t. So now, we instead of you tengok yang dah di-type, mari kita buat handwriting macam mana nak dapat jawapan PAA. Sekejap saya share saya punya apa ni? Slide. Atau bukan slide, saya punya words. Okay. Okay. Again, before this, okay, dalam Markov chain, alah, tulisan pun tak cantik. Okay, dalam Markov chain, we have alive, we have death, so we have the probability A kecil. Dalam ni dia pakai A kecil, so kita pakai A kecil. Okay, in the Markov chain, we have PAD. But in Markov jump process, we also have the PAD. We need to find PAD. So PAD, but it involves with time from X to X plus T. Same goes to here. We also have our PAA. Now we also have our PAA X to X plus T. So in the in the matrix, we have the probability here where we have AD. We also have AD here. So we're going to have our PAA, PAD, PDA, and PDD. Same goes to here. We also have AD, where we have A. Here will give you PAA, X to X plus T. We have D. Here we have PAD, X to X plus T. We also have PDA, X to X plus T. And we also have PDD, X to X plus T. And we know that both PDA and PAD is an absorbing state. So we can write this one is equals to 0, this one equals to 1. Same goes to here. This one is also an absorbing state. Maka dia adalah kosong dan 1. So now we need to find our PAA x to x plus t, or we can find our PAD x to x plus t. So here we consider that we want to find PAA x to x plus t. Okay, bila kita dapat PAA x to x plus t, we can find our transitions probability, where 1 minus PAA x to x plus t. Now, look at our PAA x to x plus t, where so yang ni dah habis I nak terus jump pergi ke Markov jump, where PAA x to x plus t, it's also equals to our TPX. So now in order to solve for our PAAX to x plus t, because it involves with time, we can solve these equations by defining your forward differential equations, where we need to find our delta t. Kalau kat sini saya pakai delta lah, you boleh pakai d pun boleh. So delta t for our PAAX to x plus t. This one, actually you have a two way to solve these equations. So for today, I will solve these equations by using the simple definitions of differential equations. Macam you belajar dalam calculus. So this delta divided by delta t, PAAX to x plus t is also equals to delta t TPX. So just now mentioned by your friend Khalis, it says that this is in terms of change of time for our derivative. So what is our, if you recall back your calculus, apakah you punya simple derivative functions or definitions of derivative? Macam mana you solve your dy dx? Amir Zakwan, boleh awak ingat saya apakah equation untuk dy dx zaman calculus dulu? Ada? Amir Zakwan? Simple derivative ataupun simple derivative of functions or definitions of derivative. Tak ada. Tak ada, saya tanya. Nurin Hannah. Boleh bagi saya balik tak? Apa you punya calculus during your calculus time? What is the definitions of derivative? dy dx. Nurin Hannah. Nurin Hannah tak ada? Oh, Nurin Hannah. Nurin Hannah? Alah, tak ada pula Nurin Hannah. Nur Hannani Nazri.
Ya, madam.
Okay, apa dy dx dalam definitions of derivative?
Kejap. Yang fx tu ke?
Ya saya.
fx gy tu ke?
Macam mana nak tulis equation dia?
Yang saya tahu fx darab gy macam tu. Saya tak
Ah,
ingat.
bukan. I tak ingat calculus. Limit h approach to zero. Functions of x plus h tolak dengan fx divide by h. Okay, kalau you ingat balik you punya dy dx, your dy dx is limit h approach to zero, fx plus h minus fx divide by h. Then you want to define your dy dt. So dy, y is your tpx, dt is your x. Then you will say that your d dt or delta t tpx is actually equals to limit. Allah, kenapa pula? Limit dt equals approach to 0, t plus dt px minus with tpx divide by dt. So how to solve your dy dx, which is limit dt approach to 0, t plus dt px minus tpx divide by dt. In order to solve for these equations, or in order to solve for tpx, okay, nak dapatkan PAA tu, in order to solve for your delta t tpx, we need to solve our t plus dtpx, which is this one. Okay, nak solvekan tpx ni, kena solve dulu delta t plus dtpx. So, we solve first our t plus dtpx. So, sekarang kita cuba solve dulu kita punya t plus dt px. What is the equations for t plus dt px? Sama dengan P Norman Arif. Kalau dalam Markov punya notation, how we going to write our t plus dt px in a notation for Markov process? Apa? Dalam Markov process punya notation, kita nak tulis apa? Norman Arif. Ada Norman Arif kat sini. Norman, cuba bagi saya dalam bentuk notation Markov process untuk T plus DTPX. Hello? Berapa? PAA X X plus T. Yes, plus DT. So T plus, thank you, T plus DTPX is the probability alive to alive for the person at the age of X to X plus T plus DT. So you can solve this PAAX to X plus C plus DT, okay, using Chapman-Kolmogorov dimensions through our YouTube punya video. Okay, kalau you tengok YouTube punya video, our Chapman-Kolmogorov equations, what is the Chapman-Kolmogorov equations? CK equations. So CK equations, usually if you look through our Markov chain, okay, if you look through our, if you look through our Markov chain, where we say that they have n-step transitions probability, where usually we refer to our time n and time n. Now, let's say you have your L, where your L is between m and n. So you want to find your Pij from time n to time n. Okay, if you refer to our Chapman-Kolmogorov, is actually the summations for K, PIK, PKJ. Now, based on our state, we only have two state, where state space kita adalah A dan D. Then we can find our PAA here, which is equals to the summations K. For K adalah PAK times with the probability PKA. Then you can expand your PAA, which is equals to PAA times with PAA plus with PAD times with PDA. So you can use this PAA to expand our T plus DTPX. Okay, so based on here, we're going to have this one equals to PAA, okay, X to X plus T times with PAA, X plus T to X plus T plus DT plus with PAD, X to X plus T times with PDA, X plus T to X plus T plus DT. Okay, then you can cancel off your probability of DA and it will give you 0. Okay, any questions so far? Ada soalan? Kasrina, do you have any question, Kasrina?
Madam nak ambil gambar je.
Ambil gambar. Tak apa, dalam video ada.
Okey.
Kalau kelas saya buat video, saya record. Tapi kalau macam discussion question, saya tak record. Okay, sebab saya nak you sit and answer the questions. Okay, kenapa you tahu PDA equals to 0? Nur Sufi, why PDA, I can say that it is equals to 0. Nur Sufi Al-Inshirah.
Ya madam, kejap
Kenapa? Kejap. Okay. Kenapa saya cancelkan? Saya terus cancelkan dia equals to 0. So, PAD darab dengan PDA, of course 0, tinggal yang atas je lah. Sekarang ni kita nak kira yang ni saja. Tapi kenapa yang ni equals to 0?
Oh, tu lain. Saya.
Nur Sufi, cepat Nur Sufi. Kenapa Nur Sufi?
Alamak madam, saya tak tahulah madam.
Sebab death ke life mana boleh Sufi?
Oh, faham.
Oh, tiba tak tahu. Tadi dah cakap dah Sufi kat atas tu. Nampak ni saya tulis dah. Kenapa PDA tak boleh Sufi? Sebab dia kosong. Dia kan absorbing state. PDD je boleh Sufi.
Faham.
Okay.
Okey madam.
Okay. Dah Then, nak buat apa lepas tu? Sebenarnya nota ada dekat yang saya type tu. saya tulis dia tak cantik, you boleh refer dekat yang Puan Diana type ni. Dia rajin type, dia type. So, now you need to solve PAAX to X plus T time with the PAAX plus T, X plus T plus DT. You can substitute this into our original informations. But before that, if you look at here, our PAA, pakai color lain lagi. Color hijau. So, yang ni, okay, kalau you tulis dalam actuarial notation to make it easy and understand, where this one we can write as dt qx plus t. Sorry, p. Q pula. Boleh tak saya tulis PAA ni? PAA x plus t to x plus t plus dt is equals to dt px plus t. Boleh ke, Farisha? And this dt px plus t is actually equals to 1 minus dt qx plus t. Nampak? Dah ada bunyi-bunyi dah nak pergi ke our dt qx plus t. Okay. You dah tahu your PAA ke atas tu, PAA x plus t plus dt is actually 1 minus dt qx plus t. So you can take our, just now, our equations where we have t plus dt px is equals to PAA x to x plus t, which is our TPX. So I can write in actuarial notation to make it easy to understand, where this is our TPX and dekat belakang tu adalah our 1 minus dt qx plus t. Then you can expand your equations. You will get t. Actually this one, kalau to make it easy, bolehlah saya tulis dulu ya. Saya tulis dulu. This one adalah times with dt px plus t, or we can write tpx 1 minus dt qx plus t. Then you expand, you will get tpx minus with your tpx dt qx plus t. Okay. Ataupun sebelum tu saya kembangkan dulu saya punya 1 minus dt ni, where I know my dt qx plus t is equals to, Allah mak kenapa color ni, 1 minus, saya kembangkan ni lagi, saya akan dapat saya punya mu x plus t dt plus with 0 dt. Kan, yang ni datang daripada assumptions number 2. Then I baru expand to make it easy. So tpx tolak dengan tpx mu x plus t dt plus with 0 dt. So this is my t plus dt px t plus dt px. So this one is actually, I can write it back into my notation for Markov process, where it is PAA. So TPX, again, kalau kita nak baca balik kita punya Markov punya notation, PAA x to x plus t minus with PAA, yang ni apa? X to x plus t times with mu x plus t dt plus with 0 delta or dt. Sekejap saya pakai d, sekejap saya pakai delta. Sorry ampunkan saya. So delta tu adalah dt. So now you can solve. Once you have your t plus dt px, again, when you look at our original equations ke atas ni, kita nak T plus dt px, kita dah cari, kita ada T px, and we can divide by delta T or dt. So, back to our equations yang atas tu, kita boleh solve our limit. Okay, saya pakai D lah ya, sebab saya dah start pakai D, sorry. dt approach to 0 or near to 0 for T plus dt px minus with T px divide by our dt. So, masukkan balik semua yang kita dah kira tadi, maka kita dapat ataupun kita tulis in dulu dalam Markov punya equations. We can write or we can have our PAA x to x plus t plus dt minus with PAA x to x plus t divide by dt. Okay. So we also can say that our limit here, we also can write our limit dt approach to 0 in the positive because it come the right hand side. So 0 ni maksudnya dia refer kepada right hand side. Maksudnya yang positive punya information ataupun positive value. So PAAX x plus t plus dt tadi ke atas tu adalah PAA x plus t minus with PAA x plus t plus, sorry, PA x plus t saja kat sini. Kan, baru darab dengan mu x plus t dt plus with 0 dt minus with our TPX here, this one. Sorry kat sini tak ada. PAA x plus t divide by our dt. So here we can cancel off PAA x plus t minus with PAA x plus t. Our dt we can cancel off with mu x plus t times with dt. So now kita cuma tinggal ini macam you belajar lah, TPX mu x plus t, where it will instantaneously change to other state. So we can simplify this. Bila kita cancel of our dt, our limit will gone. Okay, limit kita set for dt, so we cancel off our dt and dt here. So this dt is actually equals to 0 je, tak ada masalah. 0 dt is near to 0. So when we cancel our dt, we say that our limit delta dt approach to 0 is actually gone. Maka tinggallah apa yang ada? PAA x plus t mu x plus t plus with limit, kalau you nak buang nanti saya buang agak ni, delta t approach to 0 positive for 0 delta t or dt. Actually this one you can cancel off because 0 dt is near to 0 or approach 0. So end up you will get your equations adalah delta t or dt tadilah ya, d dt for your PAA x to x plus t is actually equals to kat sini ada negatif ada negatif kat sini. Okay, ni negatif ni, tinggal ini sahaja. Okay, tinggal ini sahaja, ada negatif kat situ. So then you have delta or d dt. Cantikkan sikit lah tulisan, tak tahu pula ada orang nak snap gambar. Sorry, d dt it's equals to negative PAA x to x plus t mu x plus t. Yang itulah kenapa you belajar jadi TPX, mu x plus t and so on. Tapi ini dalam keadaan PAA x to x plus t. Kita belum kira lagi lah ya. So now, how are we going to solve our differential equations? Any idea? Macam mana kita nak solve lagi ni? Kita punya differential equations. Kalau you ingat balik you punya calculus. Amni Insyirah. Kalau zaman calculus tu, macam mana you nak solve your differential equations here? Amni ada?
Ada.
Okay, Amni. Zaman calculus
ada.
tu macam mana kita nak solve differential equation?
Yang pakai chain rule tu ke madam?
Chain rule macam mana?
Yang
Macam mana nak masuk dalam chain rule tu?
bukan chain rule.
Okay. Kalau you tak ingat balik, you boleh ingat balik lah. Okay, if you look at this, kalau you dah tengok d dt PAAX to X plus T, actually, dia ada several techniques. Okay, but for this d dt PAAX to X plus T, if you refer to my video, actually that video, I put it in chapter 5, which is differential equations, but you can look at any YouTube just to recall back your calculus. So to solve this, you need to apply several techniques. One of them is separating techniques or separating the variable techniques. Okay, so to solve the tulis saya to solve differential equations. Okay, kalau you tengok format ni, because if you have this kinds of format, if it will be easier to use separating the variable techniques. Okay, untuk kat sini selalunya kita ada banyak. Satunya kita pakai, macam saya cakap tadi, separating variables. Lagi satu, kita boleh pakai integrating factor. Ataupun dalam video tu mungkin ada nama lain lah, tapi integrating factor. You macam mana nak tahu separating variable ke integrating factor ke? You kena tengok format balik lah dalam in your calculus. Kalau you ada this format, d dt PAA x to x plus t equals to negative PAAX to x plus t mu x plus t, where you can look at our, tulis kat sini untuk nota separating variable techniques. Kalau you ingat balik, kita ada ddx lah, zaman dulu belajar. ddx x square equals to xy. You put all x in one side, you put y in another side. Maksudnya dekat sini you ada ddx for x square divided by x equals to y. Contoh, kalau you ada this kind of format, you ada dua variable, satu variable you letak kiri, satu variable you tak letak. You separate the variables. That's why we call that as a separating variable. So here we have PAA, we have mu x plus t. You put all in one side, where d dt PAA x to x plus t divide by PAA x to x plus t equals to negative mu x plus t. Okay, so these differentiations or these equations, kita boleh transform dia menjadi apa? Kalau you belajar dalam tak salah saya, dalam calculus ada, dalam actual maths pun you ada pakai, dalam survival models pun you ada pakai, di mana kita pakai logarithm differentiations or dipanggil logarithmic differentiations. Logarithmic differentiations, di mana d dx log fx is equals to f prime x divided by fx. So here, in terms of natural log, you also can write these equations, or this term can also be written as d dt for the natural log PAA x to x plus t equals to negative mu x plus t. So now, how to solve these equations? Where we have d dt natural log p x to x plus t equals to negative mu x plus t. Macam mana kita nak solve equation ni? Muhammad Akil. Akil, kita dah simplifiedkan kita punya differentiations. So sekarang ni differentiations kita dah dalam bentuk logarithmic ataupun natural log. So macam mana kita nak solve lagi next step? Muhammad Akil ada? Muhammad Akil tak ada, saya tanya Muhammad apa lagi ada? Muhammad Danish. Muhammad ada dua, ada Danish. Muhammad Danish, Muhammad Rizal. Ada?
Apa madam?
Lepas ni nak buat apa Danish? Macam mana nak solve lagi? Kita nak dapat PAA, kita tak nak DDT, kita nak PAA sebab kita nak masuk dalam matrix.
One over PAA ke madam?
1 over PAA. Nak solve calculus tu, kita kena pakai ataupun kita kena integrate for both side. Ini kena recall balik you all punya calculus ni. You need to integrate for both side in order to solve for these equations. Okay, in order to nak integrate for both side, you need to let, okay, kita nak integrate 0 to t, so you need to change our t to become s lah. Okay, maka kita nak integrate daripada kosong ke t. Maka kita kata kita punya dd delta pula kejap. So dds natural log PAA x to x plus s is equals to integrate from 0 to t mu negative here. Mu x plus s ds. Okay, you can refer to our notes that I share with you, where it shows you the rest of the process, where mana dia ni? Ni lah. Okay, kita kata kat sini, solve this by applying the separating variables, where we integrate for both side here. Kalau you nampak kat sini, kita integrate untuk kedua-dua belah, kiri dan belah kanan. Bila kita dah integrate for both side, then you will get your natural log PAA x to x plus s 0 to t equals to negative integral mu x plus s ds. Then macam mana you nak hilangkan dia punya natural log? Because we want our PAA x to x plus t, so you put exponent for both side, you will end up your PAA x to x plus t is equals to e to the power of negative integral from 0 to t mu x plus s ds. So that will be your probability PAA x to x plus t. Kalau you tengok, dalam kerja dia lebih panjang daripada belajar Markov chain. Kalau you tengok ke atas ni balik, sebenarnya kita nak cari matrix ini. Kita nak cari yang ini. PAA x to x plus t is actually equals to e negative integral from 0 to t mu x plus s ds. Nak cari PAD adalah 1 minus your PAA lah, x to x plus t. 1 minus integral to the power of negative 0 to t mu x plus s ds. Maka complete lah your transitions probability matrix for this two-state Markov model? Questions? Ada soalan? Nurdania binti Syahrul Niza, do you have any question, Nurdania? Nurdania tak ada. Ilya Irdina, do you have any question so far? Ilya Irdina? Ilya pun tak ada. Nur Eliana Batrisha, do you have any question? Nur Eliana Batrisha?
Tak ada, doktor.
Okay, and seorang lagi saya tanya. Rabiatul Adawiyah, do you have any question, Rabiatul Adawiyah?
No, madam.
Okay, this is a simple method where we only use or we only apply the separating variable techniques. So I'm going to share with you. I think dalam YouTube saya dah share satu, tapi dekat chapter kat topic 5 boleh ambil lah tengok video tu. But I'm going to share with you next week ataupun next week a video from two lecturers, one from UiTM and another one from University Malaysia Pahang, UNIMAP, where we do some collaborative teaching last semester and last year. Every year, setiap tahun sekali saya akan buat collaborative teaching lah. Satu semester kod saya ajar ni, satu semester lagi kod lagi satu saya ajar. So semester ni saya buat kod lagi satu, tapi saya share video yang saya dah buat collaborative teaching where I try to invite a few lecturers lah setiap semester who going to teach you or recall back your differential equations. Okay, now we move to continue with our notes. Sekejap ya, saya patah balik ke PDF notes. Okay, itu jika dia hanya ada dua state, alive to death, and they only have one arrow. Imagine that. But before that, multiple state model, one of the most fundamental features of the simple two-state model is that it only allows for one types of transitions from alive to death. Dia ada satu transition je. Dia ada satu arrow je. But in practice, we might want to investigate a model that allow for transitions between state in both directions. Okay, alive can go to death, but death cannot go to alive. Bayangkan kalau you ada model yang lain. So this make it possible for a person to enter a particular state multiple times. Now we can extend our state model or simple alive model where we can expand. For example, like here, 3-state model such as healthy sick death model or known as the HSD model. You can see here, we have healthy go to sick, sick go to healthy, healthy go to death, and sick go to death. We have 4 arrows with the different transition rates. Kan? Itu kompleks lagi lah. Ada lagi kompleks di mana kita ada marital status. We have bachelor, widow, married, death, divorce. Now you can see here, you need to imagine in real life, we cannot only have 2-state model, we can have a multiple state model. So in the next chapter, chapter 5, I will share with you, we start with the time homogeneous and we continue with the chapter 6, time inhomogeneous. Chapter 7 is actually more on your assignment where you need to do your assignment in chapter 7. I'm going to share, but I'm not going to explain your assignment. So assignment is just an applications where a part of applications tu you kena buat sedikit simulation lah. Okay, tapi kebanyakan simulation and assignment more on the discrete compared to continuous. Jarang ada soalan continuous. Kalau ada pun in a simple form, because continuous it takes time and it takes a coding to quite complex. Okay, for the next chapter, I will share with you one of the special case for time homogeneous, which is Poisson process. Actually, Poisson process is actually come from Poisson distributions that you have learned in your statistical subject. But we try to expand or enhance our Poisson distributions when it involved with the process or stochastic process. Okay, one of the stochastic process we call which we call as a count process. Di mana count process, the best count process is a Poisson process. And Poisson process is a special case for the stochastic process under time homogeneous Markov process. So nanti ataupun kejap lagi ataupun petang saya akan share. Kita masuk dulu Poisson process, baru kita pergi not a special case, a general Markov jump process for time homogeneous model. So far, any question for today about the two-state Markov model? Tak ada soalan? I think that's all for today. Thank you very much. Assalamualaikum.
Thank you, Doktor.
Thank you,
Okay.
madam.
Kenapa tu?
Thank you, Doctor.
Terima kasih, Doktor.
Thank you, Doktor.
Ada masalah jiwa tu. Okay, bye. Assalamualaikum.